All right, this is trapezoid A, B, C, D. Not only is this a trapezoid, it's a special type of trapezoid. It's an isosceles trapezoid. The fact that it's a trapezoid tells us we got one set of parallel lines. Which lines are parallel, you might be thinking? The ones that look parallel, you silly Billy. There they are. All right, so now that we know that those two lines are parallel, what else do we know when we're dealing with an isosceles trapezoid? If it's isosceles, we know that this side is congruent to this side, meaning AB is congruent to DC. These two are the same length. They are congruent. What else do we know about an isosceles trapezoid is the fact that this upper angle here is going to be the exact same, congruent to this angle here. So we could say angle B is congruent to angle C. This is also something we know. What else do we know? We also know that angle A, the lower left angle, is also going to be congruent to angle D over here, the lower right angle. So these are congruent angles, angle A and angle D. Now, where do we get to a point where things get a little bit trickier? What I want you to do is imagine that this line here and this line here, because we're dealing with a trapezoid, we know they're parallel. I want you to imagine extending that line out, extending this line out, and then extending this line AB. If I were to continue drawing AB, we are looking at what's called a transversal, right? A transversal is a line that cuts two parallel lines. And when we are dealing with a transversal, we should know something already, and that's that this angle here and this angle here are going to be supplementary. So I can tell you right now that angle A plus angle B, when added together, is going to give me a sum of 180 degrees. Okay, this is helpful for when you are given this angle right here. You can use that value, plug it in, and say, how much am I missing to get to my total sum of 180? Those two angles are supplementary. Supplementary meaning they add up to 180 degrees. All right, well, what does that tell you about C and D? If angle A and angle B add together and make 180 degrees, angle C and angle D, they're also going to be supplementary. Angle C plus angle D also will add up to a grand total of 180 degrees. Okay, one more thing we know about an isosceles trapezoid is that the diagonals are congruent as well. They will be the same length. So if I said diagonal AC, this is going to be congruent to diagonal DB. Diagonal DB. Diagonals are congruent. So there's a lot of things we know by the fact that we're just being told something is isosceles. When we're told that, we know these two sides are congruent, which then causes a bunch of other things in the shape to be congruent as well. The angles that are on top, the angles that are on bottom. Remember, we got our parallel lines. We're going to have congruent sides on the left and right side, and then our diagonals will also be congruent. That's a lot of information, but once you memorize all of that, then you can be asked to do a little bit of algebra with it. What do I mean by that? I can give you some expressions for the distance or the length of one of these sides. You can then use algebra to solve for a missing variable and then determine how long that side of the trapezoid is. Let's take a second. I'm going to erase this, put a problem up there for you, show you exactly how to do this in a geometry class. Wow, that was quick. Okay, so now we're looking at AC being a distance of 2x plus 5. We've got an expression given for AC. We also have an expression written for DB. Well, let's look at what AC is. AC is a diagonal. Nice. And DB is also a diagonal to this isosceles trapezoid. Well, what did we just talk about? Knowing about our diagonals of an isosceles trapezoid, we know they're congruent. Diagonals of an isosceles trapezoid are congruent, meaning these are the same. Well, if they're the same, all we need to do is write an algebraic equation out, 2x plus 5. If this is the same as this, right, AC is the same as DB, write an equation saying that and solve it using your algebra skills. Line down the middle, a little bit of inverse operations, we're going to be done. So let's get our variables to the same side. I'm going to take away 2x from both sides. leaving me with 3x over here minus 4. We haven't gotten rid of that term yet, but we're about to. Let's move -4 over to there. We're going to do inverse operation of -4 is adding 4, cancels out, add 4 to 5, giving me a total of 9. 9 equals 3x. Divide by 3. 3 equals x. Now this is great if you get to this point. A lot of times I'll have students that will think that they're done. Hey, I found x. Clap it up for me, Mr. Bielik. I will not clap until you're done because I'm asking you what is the distance of AC. If I want to know the distance, I need to take my value for x and replace 3 in for the x in this expression. So instead of 2x plus 5, 2x plus 5, I'm going to say 2 times 3 because that's what x is. 2 times 3 plus 5. Now I can get 6 plus 5 and say that AC is 11 units long. Hopefully this makes sense. Study hard and good luck on your upcoming test.